Sorry about that. So as you as you remember, we had a La Nina event that started developing in mid 2020 and ending in early 2023. In general, strong La Nina events tend to persist for more than a year, but it is not so common for a La Nina event to last longer than 2 years. So it was kind of an interesting, unusual event. And as you can see in this bar graph, 2020 to 2022 La Nina wasn't that strong in terms of its magnitude compared to the previous La Nina events. But during the third year of this triple La Nina in 2022, Australia experienced some severe flooding incidents and had some record high rainfall, especially in spring over southeastern Australia. And these local climate anomalies have been studied by several different research groups, as far as I know. Before this La Nina started, we had severe bushfires in spring and summer in 2019 to early 2020. And Fasullo et al. Showed with their modeling experiments that the Australian black summer bushfire smoke induced anomalous equatorial easterlies that promoted La Nina in 2020. Also, there was this Hongatonga volcanic eruption in January 2022. And my colleague Chris Lucas noticed very unusual tropical convection anomalies soon after the volcanic eruption in the tropical Western Pacific, which was captured by this MJO strolling in its phases 1 to 3, which could have contributed to the persistence of La Nina through 2022. So in this plot, the black line shows the observed Nino 3.4 SST anomalies, and the colored lines show the ACCESS-S forecast at different lead times from 0 to 4 months. And you can see that ACCESS-S kind of reasonably well predicted this La Nina event throughout the 3 years, except for this period of predictability barrier in autumn 2022. So motivated by the very unusual atmospheric conditions of early 2020 and early 2022, we want to explore how much of this forecast scale is contributed by the anomalous atmospheric forcing by randomizing the atmospheric initial conditions. So the comparison between the standard forecast and the random atmosphere experimental forecast will show the contribution of the anomalous atmospheric forcing to the development and maintenance of La Nina for the 3 years. Furthermore, these experimental forecasts can shed some light on other climate anomalies, such as the extraordinary persistence of the positive southern annular mode in 2020 to 2022, which was likely to be mainly driven by the stronger than normal stratospheric polar vortex, but could also be driven by the La Nina conditions. So there are 3 forecast sets needed for this study. The first set is the hindcast or the retrospective forecast set of 1981 to 2018, initialized with realistic observed conditions for both ocean and atmosphere. In general, we use this hindcast set to calculate the climatology and the standard deviation. But you can also use this set to compare the triple La Nina event with previous La Nina events that occurred during the hindcast period, or assess forecast scale for other weather and climate variables. The second set is this standard real-time forecast set for 2020 to 2022, initialized with realistic ocean and atmospheric conditions like the hindcast. Then the third set is our experimental forecast set for 2020 to 2022, initialized with realistic ocean conditions, but initialized with unrealistic atmospheric initial conditions we picked from 1990 to 2012. So here I'd like to stop and ask Griff to jump in to tell us more about the details of the data sets. Griff, are you here?
Yep.
Thank you.
So we've at the dataset locations, the hindcasts are currently on NCI under the UX62 project, which is the RDSI project that stores that, and the directory is there on the slide. The standard real-time forecasts basically have been collected and they're by Eun-Pa, and they're placed in on the DX2 disk, which is our seasonal prediction disk, and basically they're the variables of interest. So the atmospheric variables of interest. If there's something there that you don't have, I imagine we can go and get it. But our intention is to eventually move these files to the GData LG87 directory so that they're more accessible. The final location, I guess, is the LG87 experiment La Nina, which is the output of model, the ACCESS-S2 model runs, and that's the full set of variables. We have noticed that that path can't be seen from ARE nodes when you get on, so you'll have to be on SSH to Guardi, log in and get access from there. And we're not sure why that is, so but we'll find out. And I think I need to raise a ticket. The time dimensions, the hindcasts is quite a long data set. It's got 9 months in there. That's quite reasonable. The forecast, due to time constraints, is only out to 6 months. And again, we'll need to get the variables for you if required. And the experiment forecast will be sent out to 4 months because that was deemed to be a reasonable amount of time to observe the things that we wanted to observe. The run dates, so there are several sets of files, I think 36 files, or 36 start dates. We've gone for the first of the month, for all the odd months, so January, March, whatever. And we've got those for 3 years. So the other thing was that there are 18-week forecasts, which is effectively 4 months. So the 32 member ensembles for the experimental forecasts are set out as E01, 2, 3, 4 to 23, but essentially correlate to the available atmospheric conditions from 1990 to 2012. I can never remember why I put that. I don't know why I draw a blank when I get to creating climatology and ensemble mean, but essentially it's just using NCKS tools to average the climatology, and they are pre-computed as far as I can tell, but I'm not exactly sure where they are. I apologize. I draw a mental blank, but yeah. And actually, no, I think the point with this was we were going to discuss whether we should pre-compute them and
Right.
where we should put them. That's right. That's what the question marks are for. Yeah, that's why I can't remember where they are. All right, so that's my bit. Thank you for listening.
Yeah, thank you, Griff. So from now on, so what should we do with this data? First of all, because these data were produced for our climate community, please feel free to use and do your own research. just tell me or let me or Debbie know what you want to investigate, so that we will avoid unnecessary overlap in our research. But for our collaborative, like community research, maybe we should aim for a peer-reviewed paper at the end of the investigation that features some major climate anomalies like La Nina, SAM, Australian rainfall, etc. And we'd like to encourage the participations of students and early career researchers in particular. And maybe we should announce the availability of the data and call for participation to the wider community like CLEX. And to encourage people to get started, maybe having a half-day hackathon could be helpful. And finally, let's use and watch the current experimental proposal page on ACCESS-Hive, which is searchable by triple La Nina as the keyword for further discussion and announcement or expression of interest. So that's all from me. And yeah, it's time for questions or suggestions. Is there any raised hands? Debbie, is there anything you'd like to add?
No, I think that's good, Eun-Pa. I guess it might be useful to get an idea of who that's currently here in the meeting might be interested in being involved in sort of in a group study on this. Maybe indicate in the chat, you're not committing yourself or anything, but it'd be useful to know who might be involved in, who might be interested in looking at this data further.
I'm thinking of a couple of people who I know couldn't make this meeting. I don't want to speak for them, but Nicola Ma and Gemma Jeffrey are both like doing research on ENSO, and maybe you just want to email them. I don't know if they'll want to do it, but just keep them in the loop. They had teaching commitments, so couldn't make it today.
I was trying to talk as well, but my computer was giving me the spinning wheel of death, and I couldn't unmute myself. So I had some thoughts. So I think it was part of the NESP. There's a proposal to have a journal special issue on the triple dip La Nina. So maybe this experiment kind of coinciding with that would be useful if other people want to look at it from a different angle to what you're doing. So that might just be another way to kind of advertise it or to utilize the information.
Yeah, so kind of initial motivation of proposing this joint experiment was actually from the discussion in the next meeting, like, because definitely there is a kind of high customer demand to better understand, the triple La Nina and its impact on Australian climate. So we thought it would be good to actually do something as a kind of larger community and contribute to the next research.
Yeah. Can you put the slides on the Hive?
Yeah.
If possible. Thank you.
Yeah, sorry, I'll just jump in from the NESP perspective. Yeah, so I think the plan, like I said to you with NESP, is to have maybe a webinar, a stakeholder focused webinar, hopefully around July, August. It would be great if we could present these results. And yeah, possibly fact sheet, or if there's a paper that comes out of this, that would be great. And also thanks for sharing with the community. It's really generous and nice. It's great. I'd love to be involved, by the way, just in any way I can.
Eun-Pa,
Yes.
I was wondering if you could reiterate what the experiment is expected to show? Like, it's the influence from the ocean, removing the influence from the atmosphere. Is that correct?
Yeah, yeah. So, for example, similar kind of experiments were already done for spring 2022 for the wettest spring over southeastern Australia, led by Lin Zhu. And her results show that, you know, there was a lot of like large magnitude of the wetness was actually atmosphere driven. So although the ocean conditions were realistic, even at short lead times, that large scale driven component was kind of only fractional. So yeah. So in terms of the development of La Nina, if we are not actually having the real atmospheric information, like which includes the volcanic eruptions or smoke, you know, how much of the magnitude of La Nina forecast can we reproduce? That's kind of the, you know, basic questions. And then, you know, the case of the positive SAM, you know, SAM can be driven by atmosphere like polar vortex, but also driven by La Nina. You know, was there any more important driver between the atmosphere versus the ocean? That kind of question be answered. Or even the negative IOD during 2021 and 2022. Yeah, which component of the system more important? So there are a lot to explore with these data. And
That
maybe
sounds cool.
Yeah, and maybe it will be a good opportunity for, you know, early career researchers or students to have a flavor of have a taste of handling forecast data and kind of understand the nature of, you know, forecast systems and so on. So I think that's another benefit.
Eun-Pa?
Kim, yeah.
Sorry, I was just going to say, how important is it that these activities are coordinated? I understand you don't want to duplicate things, but you know, you need to be comparing different things with each other, I guess, to tease out these the effects of different SAM and IOD and all the rest of it.
Yeah. So I don't know. It depends on who's interested in this collaborative research together with us versus, you know, do their own research in their own timeline. But yeah, I don't know. Like, I don't have a kind of solid ideas how to coordinate that. But I think for us, like, the first step is to get the gather the expression of interest, and maybe, you know, by knowing who's joining, we can maybe shape the kind of skeleton of the study.
I guess there are two aspects. One is that this data is out there for the community to use, just like the ACCESS-S hindcast data set is already. So anyone's free to use it as they wish. So that doesn't need to be coordinated. But as Eun-Pa said, if there are people that would like to do a coordinated study, then obviously that's also an option.
Yeah, Kim mentioned that she doesn't know how much spare time she would have to contribute, and so is Shane. I think we are all in kind of in the same boat. Like, so somehow we have to actually, you know, make this effort kind of part of our research activities, like if it is possible. So, for example, contributing this effort to the NESP project, that would be a good way of kind of make use of this effort. I'm not thinking through kind of deep investigation at this stage, because it is a community activity. So, like, any kind of contribution will be welcomed. It doesn't have to be heavily involved. Yeah, so if you can find that experimental proposal page on Access Hive, please leave your comments and expression of interest there. And maybe in a month's time, maybe I will kind of get back to you with some updates.
I put a link on the chat as well.
Thank you. Yeah, just before finishing this part, like, would people have some kind of interest in a half-day hackathon? Just maybe we can discuss some kind of major events and, analyze the data together. Yeah, anyway, that's kind of one thought, and I'm happy to make the entry line below for anyone who is not familiar with forecast data to come in or join the paper. So that's the idea. Okay, that was yeah, and maybe it is relevant question to Aidan, like, in terms of making the climatology and ensemble mean data available, like, that requires a bit extra space. And I wonder whether, that's definitely easier for people to use if we already prepare some means. But yeah, certainly it will need more space. So we need to discuss, the avenue for that.
I mean, there's plenty of scratch space depending on how long you need it to stick around for. I mean, climatologies generally don't take up a lot of space, do they? Because they're reductions.
That's right. Yeah.
But yeah, I mean, the working groups just had their allocation doubled, so there's 50 terabytes, so there's 100 terabytes in total, and that space is intended to be for short term, sort of up to a year or say. So there's no reason why it couldn't be there for a while and then deleted again if it's not required.
Yep.
And also the ACCESS-NRI is also quite keen to support training activities. So if you did need any support with sort of a hackathon, we should have a chat and talk to Roger about that.
Cool. All right. Thank you. So yeah, thank you so much for shared your interest on the chat. Like, I believe we can save the chat and at some point. Yeah. All right. Thank you. So that's all for the triple La Nina experiment related discussion. So yeah, if you want to stay for the next items for the agenda, which is more related to the ESM, if you want to stay for that, feel free to do, or if you want to leave, feel free to do so. But it has been nice to have this joint meeting and meet you, and hope to continue our collaboration through this experiment.
Thanks, Eun-Pa. I might just mention one more thing, if you don't mind.
Yeah.
So it has, a couple of people have mentioned the desire to be able to run ACCESS-S2 themselves. At the moment, that's very tricky for us for a few reasons. One, there's no documentation. So it's not like WAR for any of the supported NRI models. It's been implemented at the Bureau and there's no documentation to help someone use it. And we actually only have 3 people at the Bureau in research who can run the model. And it's set up specifically to do a task, to do seasonal forecasting. And so we only have limited knowledge in terms of how to use the system to do sensitivity and scientific experiments. However, whether or not we actually take this forward and whether or not we take it forward with the NRI depends on the demand. So if you are interested in down the track, if you have an interest in being able to run ACCESS-S2, maybe if you contact me or let Eun-Pa know, so we can actually sort of get some sense of what demand there is out there in the community.